Welcome to Blue Team Village Project Obsidian. Today we will talk about Know Yourself, Know Your Log, aka baselining. This is an essential part both during a security incident preparation and response. In preparation, to baseline and know what's normal, with sometimes or often a lot of peculiarities, and in response, to identify efficiently and in a confident manner unusual activity. What's our agenda? Try to understand what is critical in your environment. What are the key questions that should happen? And apply that to the kill chain of the Obsidian 2023 logs. As a quick introduction, at time of EDR, some practitioners may think that SIEM and log are too complex and costly and not worth of time. I believe it is still part of the permanent journey to protect an environment. Depending on your context, it's valid to say EDR would be the first step and to start with it. But eliminating log is probably not a good choice as you grow your environment and your company. Typically, most EDR are blind if an exploitation is happening only at the application level. Let's say move it. Or if we go for pure pass environment, simply you don't have any EDR. Another issue that happens is usually application logs are not standardized and complex. They are missing context. But that's what happens with a lot of logs, especially when security by design was not used. Today you have many options for logs. You can have a full SIEM, but data lake options are also very abundant. And even if you don't go there, you have the option to use bucket or storage account for keeping those logs and deciding to use them later. So why understanding your environment is critical? Why it goes often through log, not only, but log are usually very helpful to confirm what you are supposed to happen and on many aspects discover what you would not think at first that it's there. The other part is documentation, but for many, we know that documentation is not something that happen in a consistent and in a rigorous way. From a security perspective, it's really a must to relentlessly document your environment. It's really the basis to say during an incident, I know directly this matters versus this does not matter versus I need to search for. Ensure you share your knowledge and ensure there is no single point of failure. Typically, the documentation and ensuring that people know documentation is available and where it is the way to share this and ensure that nobody is a single point of failure and you don't need a rock star to be available at 2 a.m. while the person in question is on PTO on the other side of the world. So a few key questions. we want to know what's happened in the environment. We want to try to define what's normal, to define what's abnormal, because again, as part of an incident, it will ensure that we can act swiftly. And if we can't estimate that at first glance, how can we know that's normal or abnormal? Do we need to reach the product owner? Do we need to reach the security architects? Do we need to reach a vendor support? That's part of things we may want to do when reviewing logs. So now, let's dig into the data. So what is the environment of the Project Obsidian this year? Through some query inside the Splunk, we can find the list of indexes that we have. We can see some internal index like the audit and telemetry, but we have an index Linux, main, Nginx, an OS query, sysmon for Linux, and Windows. So we already have a first view of what kind of data source and probably of the environment is available. If we go a bit further, let's now list by host and with the first scene, last scene, to say, okay, we have a few Linux hosts here that are reporting through FileBit with a last scene and first scene at the corresponding date. And we can see eventually if there are gaps in the log. Last, we may say by host, we have this index. Again, it can be used to identify some gap. We see, for example, that our domain controller has both Windows index and sysmon index. But for some reason, Workstation 13 has only Windows index. That's part of question if it's normal or not. Now let's dig into the applications, or at first view the different process or service that are used inside our system. If I take the Linux index and if I try to list the different process name that applies, we can find some cron ID, or schedule tasks, some FileBit, obviously, to get the log. We can find an application named OpenPLC. We can find OS core ID, some Java app. That gives already a first view of what we can find inside this environment. If we do something equivalent to Windows through the Windows log channel, we can find some of the usual channel on the distributed COM, the event log, the Windows Manager. With the quick extract that we have here, there is no specific application, but digging through a larger data set, we will probably be identified. Knowing that sometimes Windows applications are sending directly in the application channel with a specific source name, which is not represented here, or sometimes they will have their own provider channel. It depends on the application, and that's where, again, digging into the log in advance to know what's normal or what's not normal is important. Another thing that's maybe useful is the log level. Some log have a categorization. The typical ones that we find in many applications are the critical error warning information table. Sometimes you would have also some sort of labeling to say, here it's authentication log, here it's privileged administrative activities, here it's security alert, whatever else, depending on the context. The best example on that is on Windows, where you have those log level and with error. Here we take the error level for Windows with their event ID. We see that we have multiple error on the distributed COM and Windows WMI, which seems related to timeout. Probably not important, but it's to validate in the context. The WMI can be sensitive. Again, review with the context and see if that's tied to an activity that is expected or not expected. What matters? Sometimes people know, sometimes not. Providing a view of what you see may help to identify things. Through the log, you are getting a perspective that's not necessarily what other group, operationals, business will have, and it's important to highlight what your findings and how you perceive that it is part of the normal activity or not normal activity. You may identify other things that are not purely security, but maybe are operational issue or maybe could be related to a security issue. Typically, a disk full, a partition full, out of memory, those can appear in the log and are often operational issue. Sometimes your IT group will be fully aware of that through their own monitoring, sometimes not. You may identify data that you think would have been there, and they are not. That's a gap that you want to review. Is it due to a misconfiguration, to a bug, to an ingestion issue, or something else that needs to be reviewed? There is data that should not be there. You identified some data which is saying echo hello world because the developer has tested something and has forgot to stop the test after, or you have some data that has really no interest from a security perspective or even from an operational perspective. You can identify sensitive data or risky data, typically password, token, PHI, PCI, credit cards related stuff. This normally should not be in your log. You expect to have some identifier, username, IP address, because you need that for your audit trail. But password, PHI should not be there most of the time. And for many, log can be too abundant, and the problem of having too many log is we are not finding the needle in the haystack. We want to be selective. There is no point to collect log without value, and ideally we need to be able to demonstrate this value. In a normal tuning path, you would expect that starting from nothing and growing bit by bit, tuning would give the same result that loading everything, tuning bit by bit. But in practice, tuning is never perfect, and the cost of starting with everything is often too much for most companies. So start small and iterate fast, and that you will usually give better results than starting big and having investigation not being conducted efficiently because losing time in too many logs that has not been reviewed beforehand. As said before, share and report. We want to have written documentation that's available for your whole team, the security team, but it can also help the operational team or the business team to get a different perspective and view on their environment. Who know, a few years ago when the first big OpenSSL vulnerability Heartbleed happened, many people surprisingly realized that OpenSSL supports, I don't know, 80–90% of application on the web, maybe more. You want also to document what are the working control. Again, don't document only results that are for the abnormal stuff. Document also the things that are part of the expectation, because if those are not recorded, documented, how other people will identify it. Between the normal and abnormal, you have a good avenue to identify gap and eventually suggest some remediation that may be tasked to security team or to the operational team or to the product team, depending on where is the root cause. That's all, folks. So through the few queries in your log, we have seen that it's possible to get a familiarity of your environment, to have a sense of what's normal and abnormal. More than once, you will likely find some side issue that may need a fix or not. Again, that needs prioritization. But keep in mind, always ensure to document and share your findings, because those need to persist for your whole team in a large sense in your whole company. Thanks a lot for attending this session. I hope you will enjoy DEF CON. Thank you. Have a good day. Bye. Hello. Welcome to Blue Team Village Project Obsidian. Today, we will talk about MSTICPY and Velociraptor offline collection analysis. Velociraptor is a great tool for incident responder and has a capacity to do offline collection analysis. MSTICPY has now the capacity to query the result of an offline collection, which allows integration in notebooks, and it's what we will review through this session. What's our agenda? First, to review codifying the analysis. What are the key questions we want to answer? And review what has happened during the kill chain of Obsidian 2023. Environment where we can see through the application, the service, the LNK, the MFT, the Mcache, and what are the conclusions that we can reach from this information. On codifying the analysis, security analysis should be documented. Security analysis should be repeatable. Security analysis should be verifiable. And security analysis should use a template. This is kind of the other way to say document, document, and document. Because any security investigation should be done through a team, should be verifiable by a third party, who could be an auditor, could be a lawyer or a journalist, and you want to ensure that you are not making mistakes, and peer review can apply in a confident manner. As part of the analysis of the offline Velociraptor collection, you have many options. You can do what we all start with, text file or a paper notebook, or the multiple variants that exist. Velociraptor server has a native notebook feature on VQL, but now there is a new option that's available through MSTICPY. One of the big value to me is that you could merge in your notebook data from different sources, and you have all the latitude that's available in a Jupyter notebook with all basically Python programming that you can love or hate for some. What are the key questions? Like for most investigation, we want to know what's happened in the environment, what's normal, what's abnormal, and how we would know that. Now let's go inside the offline collection. From a code initialization, at this day the PR has not been merged, but that should be done soon. Hopefully the release will follow also soon. You will want to install a separate branch of MSTICPY. Following that, we have a query provider that's named Velociraptor log, to which we will provide a directory containing the content of the extracted zip, which result in the offline collection. Usually the structure of this zip contains a result and an upload folder. In the case of the Velociraptor log, it's really the result folder with the many JSON files that are used by this provider. From the loading, MSTICPY will identify some kind of virtual queries that are part of your collection. Obviously, it will depend on what has been configured in the offline collector. In this case, for the system we will study, there are 25 queries, which, if we list them directly, are related to Windows, some to Chrome, to ForenSync, LNK, USN, and so on. Now, we can browse through this data through MSTICPY and the notebook. What's inside the environment? From the loading of the data, we know it's a Windows. Now, let's go further. What application, what activity we can find? From a process perspective, we have this virtual query of the Windows system PS list. And if we take a quick extract, we will find the usual data, the PID, the parent PID, the command line, the token information, the hash, whatever has been collected through Velociraptor, the authentic code if it applies, the username. if we go to the service, again, we will find an executable path, eventually DLL that applies, the creation time, the user account associated, the path name. All the data that we expect are part of our collection is available and can be manipulated through the usual power of Panda and Notebook. As it seems we have an end-user system, let's go about the browser activity. We can first list some of the Chrome extensions that are present. We can see their permissions, their scope, who is the author, the extension ID and the name, and which user had those. We can review the browsing activity, obviously the Chrome history as an example. We can see that our user Seth Morgan has browsed a local website which contains a backup folder with an operational "Are you ready?" guide. On this extract, we find mostly Microsoft link outside of that. In the more forensic focused data, we can list the user. Only 3 users are identified, which are the local administrator, the domain administrator, and Seth Morgan, outside of the usual system one. We can review the forensic LN key things, where we can confirm that our user Seth Morgan has browsed multiple backup folder and some other user private folder and a tombstone copy, which may be normal or not so normal. If we go now inside the record of the MFT, we can find that Nmap is present on the system. And we have some creation times, some last record change, which is likely to be the install time, the last access, we can review the Amcache, where again we will find Nmap to be present. So what matters in what we have found? From Amcache and MFT, we can confirm that Nmap was installed. In the Windows forensic LN key, we have the list of documents that were accessed by user, some org email lists, some password files, the Are You Ready guides, some CopyNet picture PNG, admin.txt, some rig notes. That doesn't seem the usual activity. We have limited browsing history, but at least the Are You Ready guide is also used, which can lead to at least some good hypothesis that the user, Seth Morgan, was doing some not really expected activity. This can be combined with other data sources, and be it from the SIEM, and more extended forensic can also provide some extra. The multiple findings will help to solidify the evidence proof. And again, you don't want to make mistakes when maybe somebody can be fired on this if you make the wrong assumption or taking a wrong decision, which create a longer or more costly incident than it should be. As usual, share and report your documentation and findings. The notebook will help to structure your analysis and identify anomalies and gaps. Through a few queries on the offline collection, eventually combined with log queries, we can get a higher confidence in activities that are identified on the system. This will allow to make more confident and timely decisions in the incident response. As usual, Notebook will help to document and share your findings. Still, always add some story to it, especially if you are passing that to your leadership. You don't want to bury them under log. Thanks a lot for attending this session. I hope you will enjoy DEF CON. Have a good day. Bye.